Okay, the 19th question related to Doppler's effect. And even in this very question, this is the second occurrence so far from the topic of wave. Okay, so here it says a source of sound S is moving with a velocity this much towards a stationary observer. The observer measures the frequency of the source as this much. That means initially the apparent frequency is this, which is equal to real frequency, and the speed of sound is given here, which is 350, and that will be 350 divided by, because the source part is in the denominator, and that will be 350 minus of 50, that's 300. That's the first data. That will give you the value of the true frequency or the real frequency. Now it says the observer, next time what happens is, we need to calculate the apparent frequency when the source is moving away. And yes, the speed is same. So in that given case, if I call this as f dash, which would be equals to f, and this would be 350, but downstairs it's going to be 400, because now it's crossing and it's receding away from the observer. That was quite straightforward. Now you solve this and you would get option number 4 as the correct option. A straightforward one and nice for those who were into the examination hall. Now it's time we move to the next question, the 20th question. 20th question, modern physics again. And this is the second occurrence from the topic photoelectric effect. 2 milliwatt laser is there, that's the power, operates at a wavelength. This is also given. We need to calculate the number of photons that will be emitted per second. You can't have a better gift than this, right? So here you get P equals to NHC by lambda. So that will give us the number of photons emitted per unit time. Straightforward. You can either go by putting H and C directly, or you can go in another thing. HC is 1240 electron volt nanometer. And finally, just be careful with the unit. Everything has to come into the SI one. You solve this and you would get option number 4 as the correct one. All right, let's move to the 21st one. 21st, from current electricity, though it requires a bit of calculation, however, it's a very, very standard and a routine article that we discuss. So there is a system of concentric sphere, and the medium between them has been kept by a resistivity rho in the space between them. So this is the case. The resistivity is rho, inner radius A, outer radius B. We need to calculate the resistance. Yes, as the current flows radially outward, the cross-sectional area experienced by the current would change. So therefore, the entire sphere as a system can't be taken. We need to go step by step. So that is where we require an integration part. So let me take a differential sphere shown by the green one. That's a differential one. And the radius, let's say, is small r. What would be the small resistance of this? That will be rho, length is dr by area, which is 4 pi r square. That's the infinitesimal resistance of this green sphere. And in order to calculate the total resistance, the limit has to go from A to B. And that's an easy integration. You need to do that. You would get option number 1 as the correct option for this question. That was question number 21. Let's move forward to the 22nd question.